Fourth grade, lesson 6.3 is simplest form of the fraction, or the reduced version of the fraction. This is a skill you will use a lot for the next several years because, as you now know, with equivalent fractions, the same amount can be represented in a lot of different ways depending on how it's cut up. But what you'll want to do is, once you have an answer to a calculation with your fraction, you will want to reduce it down to its simplest form so that your brain can more easily digest or picture what that fraction is representing. And so as you go up in math during the next several years, anytime you calculate with fractions, your final answer will be brought down to its simplest form, reduced down to its simplest form. And so this lesson is going to teach us how to do that. Not very complex, just follow along. Let's unlock this problem to make all the pieces of this come together, make those connections, puzzle pieces in your brain. Our essential question is, how can you write a fraction as an equivalent fraction in its simplest form, in its most reduced form? Let's have a look. Vicky made a fruit tart and cut it into 6 equal pieces. By now we know if she cut it up into 6 equal pieces, right? That's our denominator. Vicky, Sylvia, and Elena each took 2 pieces of the tart home. Vicky says she and each of her friends took 1/3 of the tart home. Is Vicky correct? Now, each of them got 2 pieces, right? And they're all saying, or at least Vicky's saying, oh, all of us took 1/3 of the tart home. Tart's like a fruit little pie thingy, right? Each of us took 1/3 of the pie home. 1/3 of the pie home. But we know from the question that they took 2 out of the 6 pieces. So basically what we're asking, is Vicky correct? Okay, let's do the picture here. They gave us a picture, or let's answer their questions. Into how many pieces was the tart cut? It was cut into 6 pieces. They asked it in words there. I had put it as a fraction right away. How many pieces did each girl take? They each took 2 out of the 6. 2 out of the 6. They say use a blue pencil to shade the pieces Vicky took home. Okay, well, it's already cut into 6, 4, 5, 6. And let's use blue to show how many Vicky took home. 2 out of the 6. Now they want us to use a red pencil or a red highlighter to shade the pieces that Sylvia took home. Okay, red highlighter or red crayon, whatever you've got on you. Okay, use a yellow pencil to shade the pieces Elena took I don't have yellow. I'm going to use green. That's what I have. All right. The tart is divided into 6 equal pieces, as we know. The 3 colors, 1, 2, 3 colors on the model show how to combine the 6 size pieces to make 3 equal third size pieces. We have the green third size, the blue third size, and the red third size. So Vicky is correct. Vicky, Sylvia, and Anana each will take 1 out of the 3 if you look at this in terms of thirds instead of sixths. Of the tart home. What if Vicky took 3 pieces of the tart home and Elena took 3 pieces of the tart home? How could you combine the pieces to write a fraction that represents the part each friend took home? So poor Sylvia now doesn't get any of it. Is that what they're telling me? Rude. Okay, whatever. Okay, so we had that split into 6. I'll draw my picture. Isn't it fancy? This time Vicky gets 3 pieces. I'll make her blue. And Elena gets 3 pieces. I'll make her red. Now we have that fairly split into 2 equal pieces, with each of those girls being able to take 1 of those 2 equal pieces home. So I would word that each would get 1 out of the 2 fair pieces, 1/2. While Sylvia cries because we left her out. So now that we've seen that unlock the question, let's get into what simplest form is. A fraction is in its simplest form when you can represent it using as few equal parts of a whole as possible. You need to describe the part you have in equal sized parts. If you can't describe the part you have using fewer parts, then you cannot simplify the fraction anymore. So, what we need to draw on our memory of from the previous lesson is that we kept fractions equal, if we multiply both the numerator and denominator by the same number. Well, the reverse of multiplication is dividing it. If we can divide our numerator and our denominator by the same number, whole number, and get it down to another whole number, then it's reducible. And so this one way is going to walk us through that. And again, here is another thing that the knowledge of your multiplication facts memorized through your nines makes this so much easier. So you're welcome for pushing you guys to get those memorized. Let's take a look at 2/8. I'm going to ask myself, what number can I divide both 2 and 8 by that will get me a whole number still? Well, this is divisible by 2. 2 divided by 2 is 1, and 8 divided by 2 is 4. So I could reduce this down because they are divisible by a same number. So as long as I'm dividing the numerator and the denominator by the same number, I'm keeping it equivalent and bringing it down to its simplest form. Now, 1/4 is at its simplest form because there is nothing I can divide 1 by or divide 4 by, the same number, that will get me a whole number. Other than 1. I could divide them by 1, but that's not going to change it at all. So what's the point? Other than 1, there's nothing else I can divide it by. So reducing a fraction is just dividing your fraction down to its lowest form. Here's the picture of that. We had 2 out of 8, and instead we're recutting it. It's like magically uncutting and making it cut into fourths instead, 1/4. And they show that here. 2 divided by 2 is 1, and 8 divided by 2 is 4. We uncut it, and magically, we have a magic uncutter by dividing. Okay, let's look at 6/10. Is there a number that can divide evenly into 6 and also evenly into 10? Well, they're both even numbers, so 2 can do that. 6 divided by 2 is 3, and 10 divided by 2 is 5. So we divided both the numerator and the denominator by the same number. That means they'll stay equivalent. That's fine. It's the same amount. I'm not changing the amount, just the way I cut it. And that gave me 3/5. So the simplified version, the most reduced version of 6/10 is 3/5. So if you were calculating in your math in the next couple of years, you do any calculation in your math and your answer ends up at 6/10, your math teacher's going to say, reduce it or simplify that. That's what they mean. Bring it down to its simplest form. Here it is in picture form. This is 6 out of 10. And if we do the magic uncutter here, then we're looking at not the cut in between part, but we're looking at 1, 2, 3 out of 5. Okay, another example is our brains are trying to digest this. This is the example. We have 6/12. 1, 2, 3, 4, 5, 6 out of 12. Take a look at that number, 6 and 12. Is there a number that divides evenly into both of those that will reduce this down? I could see that 2 would do that. 2 divides into 6 evenly, and 2 divides into 12 evenly. And I'm going to go ahead and do that. 6 divided by 2 is 3, and 12 divided by 2 is 6. So there is a reduced version of this fraction, but it's not in its simplest form because look at this, the 3 and the 6. There is another number aside from 1 that divides into both 3 and also into 6. 3 divides into both of those, right? So when you're trying to get to simplest form, you want to get it to its lowest form possible. So if something can divide into both of them again, you've got to do it. So I would divide by 3 here, and I would get 1 out of 6 divided by 3 is 2, 1/2. And that looks like on this drawing, if I uncut, my red's going to be my cut part, and everything else is the uncut, is that much. 1 out of 2. Oops. Try to stay on the lines, Miss Sanchez. All right. So you can divide again. We divided by 2 to get this, and then divided by 3. But sometimes you might look at that and you're also trying, just so you don't have to divide twice like that, you can try and look and see what's the largest number that can divide evenly into both of these. You might notice that 6, especially if you know your math facts, you're going to see these things. 6 divides evenly into 6 and also into 12. So let's say instead, I noticed that right away, I would divide by 6 to both of them. 6 divided by 6 is 1, 12 divided by 6 is 2, and I got to that right away instead of having to divide by 2 and then divide by 3 again. Do you see that? So as much as possible, you're trying to see the largest number that will divide evenly into both of those. And if you don't see it, it's no worries, because as you reduce it a little bit, you'll see it. It'll show up. You can divide it again like we did here. We noticed the 2, and then we noticed the 3. No problem. Okay? So, but if you notice it, go with the largest number that divides evenly into both of them. To simplify 6/10, you can combine tenth-sized parts into equal groups with 2 parts each. And all they're trying to say here, it seemed confusing at first. Oops, that's not the pointer. It seems confusing here. All they're saying is you can combine the 10th size parts into equal groups with 2 parts each. So we had the 10th size parts, and we put them into equal groupings with 2 parts each. 2 parts here, 2 parts there, 2 parts there, 2 parts there, 2 parts there. And that's what they mean by we're dividing it by 2 into 2 parts each. 6 divided by 2 was 3. 10 divided by 2 was 5. That's what they're trying to explain there. But hopefully you understood the explanation of what we're doing. If we can keep fractions equivalent by making sure we're fair to both numerator and denominator and multiplying them upward, we can also do that by dividing them downward, and the furthest downward to go is our simplest form. Another way a strategy you could use for reducing these fractions down to their simplest form is you can use common factors to write 6/10 in its simplest form. So a fraction is in its simplest form, again, when 1 is the only factor that the numerator and denominator have in common. The parts of the whole cannot be combined into fewer equal-sized parts to show the same fraction. So in the previous example, they said, I had shown you just what are you going to divide that number by, both the numerator and the denominator by. But that heavily relies on how well you know your multiplication facts, right? Or the use of a chart. Well, if this strategy helps, if you don't have those memorized and they don't stand out to you right away, then you can use this strategy. We can list all the factors of the numerator 6 and all the factors of the denominator 10. Recall, factors we were working on this way, those are all of the numbers that you multiply together to get that product. So the product is 6. You could do 1 times 6, you could do 2 times 3, and then that's it, because then it's 3 times 2 back up again, right? For 10, it's 1 times 10, 2 times 5, 3 times nothing, 4 times nothing, then we're back at 5 again. So, and 5's already up there. So here's our factors. Factors of 6 are 1, 2, 3, and 6. And the factors of 10 are 1, 2, 5, and 10. 1, 2, 3, 6, 1, 2, 3, 6, 1, 2, 5, 10, 1, 2, 5, 10. That's where I got those factors from. I'm going to make that 10 look like a 10. That 0 was funky. Then I'm going to find my largest shared factor. Well, on this one, the only shared factor is this 2. And that tells me what I'm going to divide both my numerator and denominator by. I'll divide them by 2. 6 divided by 2 is 3. 10 divided by 2 is 5. So in the earlier example, we did that. We divided by 2 because we noticed right away that 2 divides into those evenly. We noticed that. That's assuming you noticed that, right? But what if you didn't? Then you can break down the factors of the numerator 6 and the denominator 10. And then you can list them out and match them. So if you don't have your multiplication facts memorized yet, that's a strategy you can use. If you have them memorized, then what your brain is going to recognize is the reverse of it, division, that it's divisible by 2. So they're not memorized yet. Keep working on it. It's really, really, really going to help you. You keep seeing every lesson we go into that it would have been helpful to have those memorized. So keep working your multiplication during multiplication madness, but here's a strategy to assist you until then. Since 1 is the only factor of 3 and 5 that 3 and 5 have in common now, because if I did my factors of 3, remember prime numbers, 1 times 3, and that's it, he's prime. And 1 times 5, and that's it also, he's prime. So since nothing else can divide evenly into 3 and 5, 3/5 is written in his simplest form. There's nothing more reduced than 3/5 that is equivalent to 3/5. Okay, let's try one. This is number 1 on the Sharon Show. Write 8/10 in its simplest form. All right, we have 8/10. So I'm going to do this both ways. The first way is just noticing anything that's divisible, or anything that 8 and 10 are both divisible by any same number. And I notice right away they're both even numbers. So I know any even number is divisible by 2. So I'm going to go with that right off the bat. Maybe they're more divisible after that. I don't know. But I'm going to go with that to start with. 8 divided by 2 is 4. And 10 divided by 2 is 5. And that is going to be it, because there's nothing that can, other than 1, that can divide evenly into 4 and 5 both, right? 5's prime anyway, so there's nothing that other than 1 and 5 that's divisible into both, and 5 isn't divisible into 4, so I'm stuck. So 2 was the only number that divided evenly into both of them. This is the most reduced form. What if I use the other way that they showed us, where I listed all the factors of 8 and 10? We have 1 times 8 for 8, 2 times 4, and that's it. So 1, 2, 4, and 8. And for 10, we have 1 times 10 and 2 times 5, and that's it. 1, 2, 5, and 10. And there's the matching 1. So that's what we would divide into both of them. So if you don't notice right away what the matching factor that divides equally into both of them, then you can list them out like that and find it. Let's try another one. Number 2 has 6/12. Is there a number that divides evenly into both 6 and 12, a number other than 1? Well, they're both even, so 2 will divide evenly into both of them, and if that's all I notice at the moment, then I'm going to go with that. Divide by 2 here and divide by 2 there. 6 divided by 2 is 3. 12 divided by 2 is 6. Oh, but look at this. I can see that 3, 6, there's a number that can divide evenly into both 3 and 6. 3 does, right? So I'll go ahead and divide again. 3 divided by 3 is 1, and 6 divided by 3 is 2. And that's as low as I can go. That's my most reduced form. You might have noticed right away off the bat, like, oh yeah, 6 divides evenly into both of those, because this is a multiple of 6. So I'm going to do 6 right away. Miss Sanchez, why are you doing it twice? 6 divided by 6 is 1, and 12 divided by 6 is 2. There's the same answer. And if you aren't noticing what number divides into both of them equally, no worries. You have the strategy to do that. Let's get the factors of 6 and the factors of 12 and compare them. To build 6, we need a 1 times 6 or a 2 times 3 will work. So the factors are 1, 2, 3, 6. And for 12, a 1 times 12 will work. 2 times 6 will work. 3 times 4 will work. 3 times 4 is 12. So 1, 2, 3, 4, 6, and 12. And when we list them out this way, we may as well look for the largest number that matches, the greatest common factor, the factor that matches, that is the largest. It's 6, and that's what those people saw right away. Maybe we didn't see it right away, but when we list all our factors and find the matching one, ta-da, now you've got it too. So you would divide both of those by 6, and you would get 1/2. The reduced form down to its lowest form is 1/2. Let me change that color. 1/2. 1/2. Let's do the same with 2/10. I'm looking at these two numbers. What number divides evenly into both of them other than 1? 2 will. They're both even. So I'm going to go with 2. Divide by 2 to both the numerator and the denominator. 2 divided by 2 is 1. 10 divided by 2 is 5. And that's as low as it goes. How low can you go? If we needed to list our factors, then we will do the factors of 2 because that's our numerator, and the factors of 10 because that's our denominator. The factors of 2 are 1 times 2, and that is it. The factors of 10 are 1 times 10, 2 times 5, and that's it. 1 times 2, or 1, 2, 5, and 10. And the common factor is 2. And so if you didn't notice that right away, this strategy will help you find it. And then you divide by 2 to both, now that you know that 2 is their common factor, and you would get 1/5. Okay, we'll practice 2 more, and then I think you've probably got it. Let's take a look at 6/8. I notice both of these are even numbers. 2 always divides into even numbers, so I'm just going to start there. That's the first thing I check, by the way. So we're divide by 2, divide by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. And when I see that this number is 1 away from that number, I know I can't reduce it anymore. So I just stop there. So 3/4 is your most reduced form. If we need to do the factoring, 6 factors and 8's factors. 6's factors, I got the 6 from here and the 8 from here. 6's factors are 1 times 6 and 2 times 3. 8's factors are 1 times 8 and 2 times 4. 1, 2, 3, 6 are the factors for 6. 1, 2, 4, 8 are the factors for 8. What's their common factor? 2 is their common factor. And so now you would find what you would divide by. When you find their common factor, that's what you're going to divide by. The largest one that's common. If there's more than one common, use the largest one. Let's take a look at 4 and 6. I notice these are both even numbers. Any number that ends in 0, 2, 4, 6, or 8 is an even number. And I notice both of those are even. So I'm going to divide by 2 to both of those. 4 divided by 2 is 2. 6 divided by 2 is 3. And again, 2 is only one number away from 3. The next counting number after 2 is 3. So I am at my lowest, simplest form. I can do that with the factors. If I didn't notice that I needed to use the 2, the factors of 4 are 1 and 4 and 2 and 2. The factors of 6 are 1 and 6 and 2 and 3. List my factors for 4. List my factors for 6. Find the common one. It's 2, and that's what you divide them both by. I hope that all made sense to you. Again, to go down to its most simplified form, we're dividing, as long as we divide both numerator and denominator by the exact same number, we're not changing the amount of pi we're talking about. We're just magically uncutting it a little bit. We're cutting it differently than it was before, and that helps brains see at the end really how much we're talking about, because as you get working with fractions, trying to envision what 6/8 might look like isn't as easy as trying to envision what 3 out of 4 looks like. So it just brings it down so that your brain can visualize a little better how much of the pie we're talking about. Good luck. I know you'll do great.